Welcome back to a new video. In this video, we'll be going over virtualization concepts and platforms. So I'll just be looking over just one exercise really of virtual networking software, just showcasing different things, right? As far as those concepts and platforms, mainly in this case, the hypervisor, which I've used in another videos with the virtual machine. You mainly using it in like a private cloud, private cloud infrastructures, but there are multiple considerations to consider when looking to provision virtual machines, right? And hypervisors can be one of two types, type one and type two hypervisors, right? So what I'm going to do is just define and describe some compute science requirements and concepts, as well as installing and exploring the Microsoft Hyper-V application as well. So let's go ahead and get started. Now, when it comes to virtual networking software, you kind of see me utilize it just a bit during the other demonstrations of the cloud service, right? Now, what these used for, they're used to create virtual networking components, right? So now, these components are used to connect virtual or physical devices, right? And virtual networking software can simulate these physical devices and also functions the same as well. The only difference is that software is used for these devices. But first, I'm going to actually install Hyper-V. Let me swivel over to, just wanted to make sure all the servers were up and running. I'm going to swivel over to 110 here. And what Hyper-V is, I've more than likely explained it in another previous video, but it's a virtualization technology, right? Used to virtualize physical devices and resources such as like creating a virtual machine or virtual switch, right? And what I'm going to do is have it installed and explored a bit as far as the virtual machine is going to be over provision for a subscription. Let's take a look here. Let's retype. Populate at some point. Okay. All right, so let's take a look at programs. I'm gonna turn on Windows features off. All right, then let's just check this box here. Right. Now this is going to allow me to enable and install the Hyper-V feature, which may require my server to restart. Take a few minutes, but of course I'll place you guys on the other side of that. Now it's restarted, so let's actually go ahead and open it up here. There we go. Maximize that just a bit. Let's think about settings here. So we got virtual hard disks, virtual machines, and storage migrations, and session mode policies, all of these wonderful things. Just wanted to take a brief look at the settings. Now, actually, let me open it back up. Now, there is specific parameters that can be set to manage the virtual components, right? Used by Hyper-V, right? Then these parameters include where virtual machines will be stored on a specific device, and it's essential to specify the current storage to ensure the manageability of all the virtual devices, right? So let's actually take a look here as well, right? And really what it's used for, it looks like it's taking a while to load, is used just to create virtual switches to connect virtual devices, really. I can actually just cancel it because it looks like it's going to take way too long than I care for at the moment. So let's actually do here. Virtual machine, and we can see now you can create a new virtual machine and the wizard opens for us, right? And it allows us to do it on a specific device. It could be created for specific devices on the network. For example, like a web server, a virtual network can be used to connect these type of devices as well. So I'll just close that out. Now, for provisioning a virtual machine for oversubscription. Now, this application, right, in Windows can be used with virtual machine resources to demonstrate oversubscription of shared resources. And this happens typically when a hypervisor shares with virtual machines beyond physical resources or available physical resources rather on the host's hardware. Now, oversubscription of the CPU cores isn't a new concept typically. Now, this capability is largely attributed to simultaneous multi-threading or SMT, which is the, actually, let me put this back up, which is the technique used in modern processor designs that enable the processor's resources to be shared by separate independent execution threads. And they're generally used to run like parallelizing computations to increase instruction throughput, and this also allows for several virtual machines to run on a single host as well. Among other resources that can be shared, uh, memory, local storage, right? Normally, when configuring these resources for a virtual machine, they would be statically set. However, there are instances where it would be necessary to allocate it dynamically, such as having like hardware limitations or instances where it is or optimized it for currently available resources. So let's actually take a look at a few other things. So let me click here. That being said, next, we're actually going to one. Next, all right. Next, this is fine. And I'm actually going to change this to 6. Now, actually, before I continue, now between these generations, right? Usually when you select a generation, an important consideration that's determined by the image of the virtual machine is going to be created through these either the generations that you choose. For example, if an older version of the Linux OS needs to be installed, in this example, it is pretty much unimportant. No image will be loaded into the virtual machine. But just wanted to put that out there. Let's see. No, that's fine. That's fine. Let's see. Yeah, that's good. Install OS later. Yeah, that's fine. Finish, of course. And I'm actually going to create a secondary one here. So we see the first one created. I'm actually going to create a second one, but I'm not going to let you guys do that. So I'll put you guys on the other side when that's completed. All right. So now we see both have been created. So I can go ahead and move forward. Let's take a look at the settings for the first one. Right. So I'm going to take a look at the processor. Right. I'm actually going to turn virtual processors from 1 to 4. And if you don't notice already, if you take a look here, excuse me, for the percent of total system resources, it changes with it. So when I change it to 4, initially it was at 25, right? And then when I change it to 4, it goes to 100%. Now, let me apply this. I'm actually going to do the same for the second one as well. Now, as I mentioned before, with simultaneous multi-threading, right? It's what allows for the hosting of multiple virtual machines on a single host right now. This is the process of splitting a physical CPU core into virtual cores, right? And also known as threads, multi-threading, right? Simultaneous multi-threading. So allowing each core to run multiple instruction streams simultaneously rather than all of the virtual machines sharing a singular thread. Having provisioned these two virtual machines on a single host represents a simple form of hyper-converged infrastructure. Finish this out. Right. So this solution just combines storage, computing, and networking into a single system, reducing complexity and increasing scalability, of course. Now, without the ability to virtualize this infrastructure, it would have been necessary to to get, configure, and connect multiple physical assets, which is uh, a lot more complicated than it has to be technically. So with that being done, let me actually go ahead over to Task Manager here. We can take a look at a few things. And let's take a look at performance. Now, for the CPU on graph display, it'll show where it kind of indicates like a machine has like a base speed and cores. Normally, now some of the host machines resources are looking over the information provided um, on the monitor graph. So for what I just did, right, it's important to note that this host has 4 cores now, and this base speed is 2.60 gigahertz. Now, this speed, right, is the computer's processing clock speed, which determines how quickly the CPU can retrieve and interpret the instructions. Now, by setting both virtual machines to 4 cores provided, the CPU is considered oversubscribed, right? Now, as the CPU has to support these 2 virtual machines, in essence, it allows the host machine to retain both virtual machines without expanding the physical CPU, which would add cost, but will require the administrator to assess for like degraded performance beyond acceptable levels at least. Now, the CPU speeds can be measured using something like per cycle or per clock, or IPC is what it's called. Instructions per cycle, instructions per clock, I believe, demonstrating how many takes or tasks a CPU can conduct each cycle. So I'm actually going to close this up, then open this back up here, right? And let's take a look at the settings again. Right, and let's take a look at the memory. Now, as we can see the settings, right, that we have here for the memory page under dynamic memory here, with it enabled, it allows for a minimum and a maximum, right, for the utilization of the random access memory. Now, despite the fact that I set it for 4,096 megabytes has been statically set to the virtual machine, enabling dynamic memory allows for the hypervisor to perform memory ballooning, right? And this allows the hypervisor to expand the memory pool artificially by using or reclaiming, rather, unused memory assigned to the host of virtual machines. And setting the memory to weigh in this instance notifies the hypervisor to prioritize virtual machine when allocated memory. And depending on the utilization, of course, across all the virtual machines, it is possible to exhaust the available memory if all of the virtual machines simultaneously require this memory, reducing the overall performance of the system. But I'm going to change this memory weight here from low to high, with that being said. And make sure here, right now, let's take a look at some hardware. Now, unfortunately, due to my lab environment limitations, graphical processing unit cannot be added to the virtual machines through the add hardware on this device. When what a GPU does is it's a specialization processor originally designed to like accelerate graphics and video rendering for the most part, right? Now, in a different host environment that utilizes a hardware graphics processing unit or graphics card, it is possible to virtualize this resource and share it with the virtual machines hosted on it. Now, this is possible through the GPU pass-through, where the device acts as if it was directly physically attached to the virtual machine commonly used to run, through a Windows virtual machine that requires a dedicated GPU for an application to operate at its pretty much at the native speeds, nonetheless. But this brings us to the end of the video for virtualization for concepts and platforms. All right, just for a brief recap, I defined and described computing sizing requirements and concepts. They also installed and explored a bit for the Microsoft Hyper-V application as well. This was definitely a lot of fun. Can't wait to get to the next one where we actually do some cloud migration techniques. In the meantime, till then, stay curious, stay secure.